For factoring, we pull an algebraic expression apart into parts that can be multiplied together. For example, we can look at the number 20. 20 has these following factors. We can break it down into 4 times 5, which can be further broken down into 2 times 2 times 5. So 20 has the prime factors of 2 times 2 times 5. Go ahead, take the number 100 and try to break 100 down into its prime factors. Alright, for 100, we can start with, let's say, 4 times 25, which can be broken down into 2 times 2 times 5 times 5. Let's look at one more. We can look at, say, 28. 28, which is 4 times 7, which is 2 times 2 times 7. So the same thing that we can do with these numbers and breaking them down into prime factors, we can also do with polynomials. We're essentially undoing the multiplication process that we did in previous videos. There are 4 particular methods that we'll look at. The first method is the greatest common factor, or GCF method. For the greatest common factor method, we want to try to look at every term and find the factor for that appears in every term. The process and the easiest way to go about this is to look at the coefficients in the terms first. So we look at our 3 terms in this first example. We have coefficients of 12, -4, and 8. The greatest common factor to all 3 terms is 4. Since 4 goes into 12, 4 goes into 4, and 4 goes into 8. Next, we want to look at the variables one at a time. The first variable we'll look at is x. And since x appears in every term, we know that x is a factor. But we have to figure out how many x's we can factor out. So we look at the exponents of 5, 2, and 3. So we know, since 2 is the lowest, that we can factor out at least 2 x's from each term. Lastly, we see that z is also a factor in the terms, but it's only a factor in the last term. So z will not be able to factor out of every one of these terms. Therefore, our greatest common factor of this polynomial is 4x squared. So now we factor that out. We take 4x squared, which leaves 3x cubed in the first term, minus 1, plus 2xz cubed. Make special note that the second term we do leave behind a 1. That 4x squared doesn't just disappear. And the way we check this is we multiply back through. So once we distribute the 4x squared, we find we have 12x to the 5th minus 4x squared plus 8x cubed z cubed, which is the same as what the polynomial we started with. So here is our final answer. Go ahead, try this next example on your own. Pause the video and resume when you're ready to check your answer. Alright, for this second one, we can see that a squared minus b is common to both terms here. So we can pull out the entire chunk of a squared minus b. This leaves behind a 1 for the first term, and a minus 3 for the second. Again, we always want to double check by multiplying through. And we find that we're left with a squared minus b minus 3 times a squared minus b, which is the same as what we started with. So our final answer is a squared minus b times 1 minus 3, which can be reduced even further into 2a squared minus b. Method 2 will be in the next video.